Recently, a post by Synchronization on Instagram was brought to my attention. He created an animation of a car drifting through letters and cavalry using forged dynamics, and the result is just really fun. I decided to recreate this animation my own way in After Effects. And along the way, I thought, why not make the car 3D? In this tutorial, I'm going to show you how to combine the Newton physics engine with the new 3D capabilities of After Effects. The goal? To show you the workflow to recreate this animation entirely within AE. Alright, let's get into it. Let's start by creating a new composition, 1920 by 1080. I set the duration and hit OK. First, I create the background with a text layer repeating the word sand. The goal is to cover the entire surface. I copy and paste the word several times to fill the whole frame. Then I clean up the layout by removing unnecessary empty lines, and I adjust the color to get a sand tone. Crucial step before physical simulation. I convert the text into shape layers. Without this, Newton won't detect the objects. Then I delete the source layer. Now, let's prepare the car animation. I create a new composition and use a simple triangle as a visual guide. To get organic movement, I use the motion sketch tool. I start capturing and draw the path with the mouse. Since the manual path is a bit shaky, I apply the smoother with a tolerance of 10. The curve is now clean and fluid. The triangle isn't oriented correctly, so I enable auto orientation. Then I rotate it 90 degrees to align it with the path. And I import the car visual. Let's open Newton. If I hit play, objects fall due to gravity. So I set gravity to 0. The guide triangle needs to follow the animation defined in After Effects, so I set it to kinematic mode. Checking the animation, I notice a problem. The triangle is oriented wrongly from the start. I immediately go back to After Effects to fix its first keyframe at frame 0. Once fixed, I go back to Newton. For the change to take effect, I select the object and hit Reset Body Transform. To simulate drift physics, the car must be a dynamic body. I start by adjusting the car's position and orientation so it matches the guide triangle. I select both objects and add a weld joint to link them. Then I move the anchor point to position it roughly between the front wheels. I increase the sub-steps to improve simulation precision. In the preview, the movement is too rigid and doesn't look like a drift. I go back to the joint settings, I increase the tension, and most importantly, the damping, which I push towards 1. Now we feel the inertia. The rear swings out while staying hooked to the trajectory. I export the animation. Back in AE, I open the composition created by Newton and hide my triangle. I copy my car layer. I open the composition with my text and rename it text. I paste the car animation. Then I relaunch Newton. Newton offers to separate my letters into independent layers, which I accept. Then I wait for it to separate the shapes. The software warns of a high polygon count. We'll fix that in a second step. But first, I go back to AE. I can delete the original shape layer. And I select all my letters and center their anchor points. And I return immediately to Newton. All my letters are centered because I moved their anchor point. I select them and right-click, Reset Body Transform, so they return to their original position. As in my previous simulation, The car must resume the animation from AE, so it must be kinematic. To optimize fluidity, I select all elements and check Use Convex Hull in the advanced settings. I also reduce the mesh precision to 1. The simulation's preview will be much smoother. I set gravity to 0, increase substeps, and set collision tolerance to 0. Without adjustment, the letters slide indefinitely at the slightest contact, like on ice. We need to break this movement. I add linear damping. And to prevent the letters from spinning chaotically, I raise the angular damping to around 6. I also reduce friction. The behavior is now correct. I proceed to a first render of this version. The simulation matches what I was looking for, an interaction where elements remain displaced. Now let's move to a second version where the letters return to their place. Back in Newton, I start by saving a scene snapshot of my current scene. This will allow me to compare my different iterations. For this new iteration, I want the letters to return to their initial position. I change their type to AE-matic. White links appear, acting like return elastics. I'll hide them in the options to better visualize my simulation. Upon launch, the return is too fast. To correct this, I select my objects by color, then strongly increase the amatic damping. The return is slowed down, but I decide to push the setting even further. I create a new snapshot of this version. I can now instantly switch between my previous dynamic scene and this new kinematic version to compare effects. The result suits me, so I launch the final render. I open this new composition and make a preview of the animation. I then place this composition into a new composition. I enable the 3D option on it. I add a camera to explore the scene. I can now zoom, rotate around the action. It's pretty cool, the scene comes to life. But my text layers are pixelated when I get too close. I'm going to enable the continuous rasterize function on this composition, then 3D on all my layers inside the animation composition. Impressive, isn't it? I switch the renderer to Classic 3D. It seems more performant for this kind of very simple scene. And then, I thought it was nice, but that flat car wasn't very cool. Especially since with recent updates, After Effects can now import real 3D objects. So I import a 3D model and create a new composition with my model inside. After Effects asks me to switch the 3D engine to Advanced 3D to manage my 3D model. It's quite performant. So, I'm going to create a new composition. I'll call it 3D car. I go back to my composition. I go get the image of my car with its animation, copy and paste it into this new composition. Then, I create a new camera from my view. and drop my 3D model into this composition. I parent it by holding Shift to my image. This allows me to link my 3D model to my image, but also to retrieve its position, scale, and orientation. Okay, there are a few modifications to make, but we can see my 3D model is centered on my image. First, I'll modify the anchor point of my car so its wheels are positioned at 0, meaning the anchor point will be located at the contact level between the wheels and the ground. Once that's done, I can modify the orientation of my car so it's correctly aligned with my original car. Now, it's correctly oriented, the wheels are nicely sitting on the virtual ground. I see it's slightly too big, so I modify its scale. And there we go. I switch back to camera view and now my car, my 3D model, correctly follows my image. I create a solid that will serve to receive shadows in my scene. I switch it to 3D. For lighting, I'll use a 360-degree HDR photo. I drop it into my composition. I hide it and place it at the very bottom of my composition. Then, I create a new light and choose the environment option. In its settings, I choose my HDR map as the source. Then, I make sure this light casts shadows. I go into the material options of my solid and set cast shadows to off and accept shadows to only. The problem is the orientation of my lighting doesn't match my scene. I'll have to tilt my scene. For that, I create a null object that I switch to 3D, select all my objects except my 3D model, which is already linked, and parent all these objects to my null object. To see the result, I switch to custom view, and I modify the orientation by -90 degrees on the x-axis. I can switch back to camera view and delete my null object. Let's look at my renderer options. For my render to be performant, I chose these options. I find my lighting a bit dull, so I go back to my light options and increase the intensity. I'll also change my background color to better see my shadows. And here, I can verify my car is well grounded and shadows are correctly projected. Perfect. I can start gathering all my elements. I'll start by reorienting the scene with my typography like I did with the composition with the 3D car model. So I create a null object, link all my elements to this null object, and tilt everything on the x-axis as I did previously. Now, I can delete my null object and my camera, and I'll import my 3D car composition. I create a new camera. I select it. I go into the menu and choose Copy with Property Links. Then I go into my 3D car scene and paste it. This step is essential. It creates expressions that connect the two cameras. From now on, any camera movement in my final composition is instantly replicated in the 3D scene. This ensures perfect synchronization between my two render engines. We're going to modify my scene a little bit for performance issues. We see I have a problem with shadows. I'll rename my solid to Shadow Catcher and Parent while holding Shift this solid to my 3D model. The goal is to limit shadow projection. Of course, I need to orient it correctly too. I scale it. And we can see my shadow is now linked to my car. I apply an ellipse mask on this solid. And modify its feather to soften it. And here is the result. I can return to my final composition. I'll put a colored solid in the background. So I have my scene with my 3D object with its shadows and then my animated typography. And all this is interactive, meaning if I move my camera, my two compositions are modified. There you go. And for my final film, I created several scenes like this one with different camera angles that I could edit to realize this sequence. To gain efficiency when editing the different sequences, a little tip. I place the master camera directly in one of the compositions, text or 3D model. This allows for much faster previews to set up the shots. In summary, this project perfectly illustrates the efficiency of a hybrid workflow. We used Newton to manage the physical complexity and inertia of elements in 2D, while leveraging the advanced 3D engine for a realistic vehicle render. The secret lies in this bridge created between 2D and 3D thanks to camera synchronization. It's this method that allows us to obtain a result that is both organic and technically polished directly inside After Effects. Thanks for watching. If you found this workflow helpful, smash that like button and subscribe to the channel for more motion design tutorials. Don't forget to check out our Instagram for some inspiring content. See you in the next one.